Welcome back to Mr. Class. Congratulations! You are going to complete chapter 1 after this video. These are the objectives in this lesson. First, we need to define the limiting reactant. Next, we have to identify limiting reactant and excess reactant through calculation. After identify the limiting reactant, then we are able to determine or calculate the amount of product and also excess reactant that left over. Now let's look at the definition of limiting reactant. Reactant that is completely used up and hence they will limit the amount of product formed. While excess reactants bring the meaning of the reactant that you have is more than required. For example, if you wish to make cupcakes and enter to the kitchen, you notice that there are 1 kilogram of sugar, 1 kilogram of flour, and then 5 eggs. So when definitely you will know that sugar and flour will be in excess, while eggs will be limiting reactants in this case. And how many cupcakes that you can make will be depends on the number of eggs that you have. Let's check out with another daily life example. Now you are going to make cheese sandwich and then you have 9 slices of bread and 3 slices of cheese. Yes, in this case, cheese is the limiting reactant and 3 sandwiches are made. So again, when we apply the definition of limiting reactant, we notice that cheese is used up and then they will determine amount of the product. Okay, these are the 2 keywords that is important for the definition limiting reactant. While break will be the excess reactant. Now we have 3 brides and 4 grooms. Who is limiting and who is in excess? Yes, bride is the limiting while groom is in excess. The pattern of this example is quite similar with what you are going to solve in tutorial question. Okay, but this example is still very daily life context. Okay, a restaurant organized a perfect match and then there is 14 single men and 9 single ladies join. In the middle of the restaurant there is a dance floor. Once the romantic music is played, how many pairs can be in the dancing floor? So because of we know that normally there is 1 man with 1 ladies, then there will be 1 pair. So now because here we have 14 men and 9 ladies, so total in the dancing floor supposedly is 9 pairs. Next part of the question, who are playing an important role to determine the number of pairs in the dancing floor? So the answer is ladies because the number of ladies are limited and they are completely paired up. So after they are paired up, means that no more new couple will be inside the dancing floor. Okay, so again here we want to emphasize 2 keywords for the definition of limiting reactant. They will use up and then limit the amount of product. Next, men or ladies are left over. So obvious, men are left over. How many are left over? So how you get 5 men? Because just now we say there are 14 of men and then 9 ladies. So when 9 among of these 14 pair up with the ladies, so we minus 9, so left over is 5 men. After 1 year, only 7 pairs are married. So what is the percentage of successful couple through this activity? So just now we already mentioned there is 9 pairs, and then now only 7 pairs are married. So we want to know what is the percentage of successful. So you are going to use 7 over 9 multiplied by 100%. So the successful rate is 77.78%. So this later I want to continue with the theoretical U, okay, in the next slide, and also the actual U or percentage U. Okay, so here the meaning of U is more to like product. Okay, so this question that I'm going to, based on this question, the theoretical U supposedly is 9. Okay, because there is 9 pair, so theoretically we hope all the 9 pairs are success, but in actual they are only 7 success. So when I use the actual over the theoretical U over 100 multiplied by 100%, so this 77.78 will be considered as percentage U. Okay, now we relate with the chemical reaction. Okay, we don't get what we supposed to get. Okay, so what is actually we obtain is called actual yield. Like just now we have 7 pair get married, so that is the actual yield. Okay, actually what happened. So normally when we solve the question, the actual yield will be given in the question. Okay, while theoretical yield is the maximum amount obtained through stoichiometry. So means that you have to determine based on calculation in the step of compare. Okay, and then you will get the number of mole. If you still remember, these are from previous video. Okay, I think when you do experiment, you always notice actual use is always less than theoretical use, because there is some factors make that the actual use is less than theoretical because of experiment condition, experiment technique, or the instrument. So if we want to get the percentage yield, always use the actual yield divided by the theoretical yield and then multiply by 100%. Okay, one more example before we go into the tutorial question. You have 30 KMnOs, but then end up only 24 popcorn. So means that 24 is the actual yield. So when you do the popcorn, you hope that all these 30 are popped out. So now this one we will consider as theoretical. Okay, because maximum you supposedly will get 30 popcorn. It is unable to have 35 popcorn because you only have 30. So means that 30 is the maximum amount that possible you get. Okay, so after that we want to determine the percentage yield. So we use actual divided by the theoretical and then multiply by 100%. So end up this is 70%. So do keep in mind that the percentage yield always will less than 100%, because just now we already mentioned that actual yield always less than theoretical yield. This example is quite similar with the tutorial question. So now let's go through the question first. You are notice that 2 number of mole are given. One is nitrogen monoxide and the other one is oxygen. Okay, Before we continue, let's compare this question with the question in the previous video. You will notice that in this video, you are given two number of mole. While in the previous question, you only given one number of mole. So basically, if you notice the question given us two number of mole, we need to identify limiting reactant before continue with further calculation. However, if you recall back in the previous video, always given us one number of mole and we no need to identify limiting reactant because there is only one information, so we will directly assume that substance is the limiting reactant. Got it? Yes, very good. So, however, the working step, no matter is with identifying the limiting reactant or no need to identify the limiting reactant, the working steps are still quite similar. So, we recall back, first we need to have equation. That's why you see in this question number 1, they ask us to have the equation. Okay, first is equation. Second, we will find out number of mole. Okay, but in this question, number of mole is given directly, not like previous video. They give us the mass, so we have to convert mass into number of mole. Okay, step 3, after we get the number of mole, is step 3. So we're going to do comparison. So we compare 2 mole of NO with 1 mole of O2 because these are the two information that we have. Okay, and then we do the calculation, substitute what we have in the question. When you do crossover multiplication, so number of mole is in this here. Step number 4, you will calculate the number of mole of oxygen. So remember, if the one that you calculated based on stoichiometry, this is the number of mole that needed. While in the question here, 0.886 and 0.503 is what you have. So now, the step number 5 will be comparing what you have with what you need. Okay, in this case, you have 0.503 more oxygen, but you only need 0.443 more oxygen. So means that oxygen that you have is more than enough. So when it is more than enough, recall back to the definition. So we know that this oxygen is in excess. If oxygen is in excess, so nitrogen monoxide will be the limiting reactant. Because we only have 2 reactants, if one is in excess, automatic the other one will be limiting reactant. The other way around, if you notice that NO is limiting reactant, then oxygen will be the excess reactant. Okay, in the previous slide, we compare NO with oxygen. Now in this question, we're still using the same question, but the method now is still the same, only we compare oxygen with NO. Okay, previous slide is NO2 oxygen. Okay, this is in the previous slide. In this slide, we compare oxygen with NO. Okay, no matter which one you use, you are going to get the same answer. Okay, so again, we repeat for the third part, do the comparison. And then we use crossover multiplication. So we get number of mole of NO needed. Okay, again, this is in the question is number of mole that you have. Okay, so now we do the comparison. you have 0.886, but you need 1.006, which is mean NO is not enough. When NO is not enough, so it is limiting reactant. Okay, so here just want to do a quick summary. In the question, number of mole in the question always refer to number of mole that you have. Okay, when you get from the stoichiometry, the number of mole that you get from the stoichiometry calculation is what you need. Always compare what you have and what you need to identify enough or no. Okay, if enough, it is excess. If not enough, it is limiting reactant. Question number 3. Calculate the mass of nitrogen dioxide produced. Okay, if you still remember, in the previous slide, we already go through step 1 up to step 4. Okay, so basically in this question, we are going to use step number 5, which is we want to determine number of mole. Okay, however, we still need to do comparison. Okay, because in the previous slide, there are two number of mole. So which number of mole we are going to choose to do comparison? Always choose the limiting reactant. Okay, always choose limiting reactant after we identify the limiting reactant. So now we will compare NO with NO2, and then we will get the number of mole of NO2, and then step number 5, we are going to do the calculation to find out the mass of NO2. So again, just want to do a reminder. We compare NO with NO2 because NO is limiting reactant. Okay, this is the reason why we choose to compare NO with NO2. Okay, the reason because NO2 contains nitrogen, so choose to compare NO. This reason is no. Next question asks us to determine the volume of excess reactant. So based on previous question, we already have idea NO is limiting reactant. So I simplify with LR. Okay, only use in our discussion only. You cannot write LR in your answer script. Okay, so and then oxygen is the excess reactant. Okay, so as usual, we no need to have a balance equation because in the previous question we already done it, and then we also no need to determine the number of mole because question is given. So number 3, we need to compare. So this time again, we need to compare what the question asks for, which is excess reactant. In this case, we already know is oxygen, and then we always will compare with limiting reactant. Okay, so that's why number 3, compare limiting reactant with excess reactant. And then number 4, we will find out number of mole of oxygen that react, okay, or needed. Okay, because of we want to find out excess, so we are going to use minus what we have with what we need. So after we minus, the number of mole of oxygen excess is 0.06 mole oxygen in excess. and then we multiply with 22.4 decimeter cube per mole because the condition of the gas is found at STP. Okay, press the calculator. Volume of oxygen that left over is 1.344 decimeter cube. Oxygen left over. Okay, number 5. If the mass of NO2 produced is 38.4. If you still remember just now, before we enter the example here, we have to mention the mass NO2 is the product. Okay, so it's considered U. Okay, product that given in the question, we will consider it as actual U. Okay, while if we want to determine percentage U, we are going to use actual U divided by theoretical U. So actual U given in the question, 40.8 gram. This one is from question 3. At where you get this answer through stoichiometry calculation. Okay, so which is theoretical U. So press the calculator, you will get the percentage U is 94.41%. Okay, let's continue with tutorial question number 7. A reaction between 20 gram of aluminium with 300 ml of 0.5 molar sulfuric acid will produce aluminium sulfate and also hydrogen gas. So recall back the working step, always in the stoichiometry is first step has equation. Okay, so we have a equation. Second, we are going to find number of mole. So for aluminium, we will going to use mass over molar mass. 0, so equal to 0.741. While for sulfuric acid, we will going to use formula mv over 1000, which is equal to 0.15 mole. So as we already mentioned before, in the question, if there are two number of mole are given, so basically means that we need to determine the limiting reactant. Okay, and do keep in mind that the number of mole that we determine in step 2 here is referring to what are given or what you have. Okay, what you have. Okay. Step number 3, we will continue to do comparison. Okay, we compare 2 mole of aluminium react with 3 mole of sulfuric acid, and then in this case we choose to compare aluminium with sulfuric acid. It is okay if you want to choose to compare sulfuric acid with aluminium. Either one pair is okay. So after we do the calculation and then we get the number of mole in step 4. So do keep in mind that number of mole that you determine in step 4 is what you need. Okay, so before we want to determine the limiting reactant, we are comparing what we need, okay, with what we have. We have 0.15 mole of sulfuric acid, but we need 1.1115 mole. So from here, we know that it is not enough. Okay, not enough. When it is not enough, so the sulfuric acid will become limiting reactant. Okay. Okay, now continue with second part of the question. We want to determine mass of excess reactant after. Okay, the keyword here is after. the reaction. Means that we want to find how much of the excess reactant that is left over. So again, after we determine the limiting reactant, we always will compare limiting reactant with the substance that want us to determine in the question. So in this case, we are going to compare limiting reactant sulfuric acid with the aluminium, because in the question only have two reactants. If sulfuric acid is the limiting, then automatically aluminium will be the excess reactant. So this is step number 3. And then we do comparison. We found out that we need 0.1 mole of aluminium to react. But then when in the previous question, we determined that there is 0.741 aluminium that we have, and then 0.1 more is what we need. So we do the minus operation, then we will know this is leftover. Okay. So after we forget the number of mole of leftover, then we can determine the mass by multiplying with the molar mass. So the final answer is 17.31 gram. Okay, now we continue part 3 of question 7. Determine the percentage yield. So we know the formula for percentage yield is actual yield over theoretical yield multiplied by 100%. If the actual mass, so in this question, they already highlight for us, the actual mass is 16.5 gram. Okay, so means that we are going to determine actual yield is given, theoretical yield is unknown yet. So we need to find out the theoretical yield. So as usual, when this kind of question until this step, we no need to write again the balance equation, and we no need to determine the number of mole because we already do these two steps in the first part of the question. So now based on the question, we have to direct to step number 3, which we need to do the comparison. In this case, we are going to compare sulfuric acid with aluminium sulfide. Why we choose sulfuric acid? Because sulfuric acid is limiting reactant. Why is aluminium sulfate? Because request in the question. Okay, so when we use a comparison crossover multiplication, we will get a number of mole of aluminium sulfate produced is 0.05 mole. Okay, this is considered step 4. So we cannot directly use 0.05 mole into this formula because the mass given in mass is given in the question. So we have to continue like step number 5. We need to find out the mass of the aluminium sulfate by multiplying with the molar mass. So we get 17.1 gram aluminium sulfate, which this is the theoretical yield. So then next only we will substitute the actual yield and the theoretical yield with the same unit, which is in gram, into the formula, and then pressing the calculator, we will get the percentage yield is 96.49%. So reminder again, if you want to determine the percentage yield, make sure the actual yield and the theoretical yield must be in the unit of gram or milliliter when it is about the volume. Okay, don't substitute number of mole in the formula of, okay, don't substitute number of mole in the formula percentage yield. Okay, now look at question number 8. Go through the question. We have the idea that 1.71 exponent 3 gram of impure sample of calcium will react with 1.01 exponent 2 gram of vanadium oxide. And then 50 gram of vanadium will be produced. So in this case, this base cannot use to determine number of mole of calcium. Okay, because cannot use to determine number of mole of calcium because this sample of calcium contain impurities. Okay, do keep in mind. So next we look at what the question wants us to find. Determine number of mole of vanadium. So in the question here, we are given the mass of vanadium and also the atomic mass for vanadium. So by using mass over molar mass, we are able to determine number of mole of vanadium, which is 0.982. Okay, now we are in the part B for question number 8, which the question asks us to determine limiting reactant. Based on previous question, we say that if there is two information about reactant are given, we need to determine the limiting reactant. But in this case, we cannot compare these two reactants at the same time because sample of calcium given contain impurities. Okay, so we cannot use the mass to determine the number of mole of calcium directly. So in this case, we have to use vanadium to compare with the vanadium 5 oxide. So we will start with step 3 in the working step. We compare vanadium with the vanadium 5 oxide, and then we notice that there is only 0.491 mole of vanadium oxide is used in producing 0.982 mole of vanadium. So now we want to check this amount vanadium 5 oxide is how many mole. Okay, so we use mass over molar mass to determine mole of vanadium provide. Okay, 101. Okay, in the question here is the number of mole given. And then from the stoichiometry comparison is needed. Okay, so based on the question here, we are provided by 0.555 mole of vanadium oxide, while we only need 0.491 mole of vanadium 5 oxide. So when next we are going to do the comparison. When we do the comparison, given is more than, where we notice given is more than needed. So vanadium 5 oxide is excess reactant, and then hence the calcium will become the limiting reactant. Part 3 of the question is asked us to determine percentage of calcium in the impure sample. So basically means that we have to find out mass of calcium over the mass of sample and then multiply by 100%. Okay, so in this case, we are going to compare vanadium with calcium. Okay, or we also can compare vanadium with vanadium 5 oxide. Okay, let's check out with the vanadium with calcium first. So if we want to compare vanadium with calcium, so it's back to step 3, compare based on the equation. 2 more vanadium produced by 5 more of calcium. So in the part 1, we already calculate only 0.982 2 mole of vanadium are produced, means that we need 2.455 mole of calcium. Okay, so this is considered step 4 lah. However, we also can use vanadium 5 oxide compared with the calcium. So if we want to use vanadium 5 oxide compared with the calcium, you have to make sure number of mole that you substitute here is the number of mole needed. Okay, we cannot substitute the number of mole given. Okay, because in this case vanadium 5 oxide is the excess reactant, so we have to use number of mole needed. Okay, because vanadium 5 oxide is in excess, so we have to use needed, not given. Okay, no matter which one you use, please check out here, the mole of calcium react is always the same, 2.455 mole of calcium are reacted. So when we have this number of mole of calcium, so we can convert number of mole of calcium into mass by multiplying with the molar mass, and then we over, so we get the mass of calcium, and then over with the mass of sample, multiply by 100%, we will get the percentage by mass of calcium in the impure sample. Okay, now let's proceed to question number 9. A sample of 1.55 gram of iron ore. So what is inside the iron ore? So basically it will have contain iron plus impurities and other substance lah. Okay, dissolve in an acid, so the symbol for acid is H+, in which the solution will be converted to Fe2+. So means that from Fe, when dissolved in water, iron or dissolved in acid will become Fe2+. Okay, then the solution form is titrated with KMnO4. So means that this Fe2+ later react with KMnO4, which will oxidize the Fe2+ to Fe3+. While MnO4 negative actually is from the KMnO4. Okay, are reduced to Mn2+, and 92.95 ml of 0.02 molar KMnO4. So with this information, we are able to determine number of mole of KMnO4 required for the titration to reach equivalent point. Okay, so we look at the question. What the question wants us to do. First step is balance the equation for titration. So recall back when we do the titration, actually we are titrate the Fe2+ with the MnO4 negative. Okay, so means that from here, we are going to write the equation Fe2+ plus MnO4 negative produce Fe3+ and Mn2+, which is considered as acidic medium. Okay, so this one I will not go through with you. I already guide you to get what you need to do for this question. So now you are the one who going to balance this redox equation in acidic medium. And the answer is given here. After writing the balanced chemical redox equation, then let's proceed to calculate the percentage of iron in the sample. So indirectly, we know that we need to get mass of iron and then over mass of sample. So at where the sample is 1.55 gram. Okay, and then multiply by 100%. Okay, so the most important part again, we need to find out the mass of iron. So as usual, step 1, we need to have chemical equation. So we already have equation here from part 1. Now second, we're going to find the number of mole. So refer to this question, we only able to find number of mole for KMnO4. So number of mole of KMnO4 will be equal to number of mole of NMO4 negative. Okay, because 1 mole of KMnO4 when dissociate, it will produce 1 more K plus and 1 more MnO4 negative. Okay, so we are going to use MB over 1000 to get number of mole of MnO4 negative. So as usual, after we get number of mole, we need to do the comparison. Okay, in this case, we are going to compare MnO4 negative with Fe2 plus because we want to determine the mass of iron. So step number 3, we do the comparison. And then step number 4, we identify the mass of Fe2 plus. So again, 1 mole of Fe will produce 1 mole of Fe2 plus. Therefore, number of mole of Fe2 plus and number of mole of iron are similar. So continue with step number 5. We're going to find the mass of iron. So after we get the mass of iron, which represent this, and then we can substitute into the formula to determine the percentage of iron in the sample, which final answer is 33.52%. Okay, all the tutorial in 1.3 are completed, discussed with you. So later you may continue with the KMfriend question. Okay, so now before we end this video, I still need to recall two more concepts with you. The first one is the dilution. Okay, in Bahasa we call pencairan. So basically a dilution process can be done by adding the solvent. Okay, so when you're adding the solvent, the number of mole of solute before dilution and after dilution still remain the same. So that's why the number of mole also remain the same, at where we will simplify this process using the formula M1V1 equal to M2V2. Okay, so do keep in mind that when we do the dilution, there is no addition or removal of solute. We only add in the solvent. Okay, let's look at one example at where dilution process is involved. A particular analytical chemistry procedure required 0.05 molar potassium dichromate 6. What volume of 0.25 molar potassium dichromate 6 must be diluted with water to prepare 100 ml of 0.05 molar potassium dichromate? So basically, I think you will get the idea. At first, we have a more concentrated potassium dichromate 6, which is 0.25 molar. And then we want to prepare a 100 ml 0.05 molar potassium dichromate 6. So at here, we have no idea what is the volume that we have, but we know that we need to take out some of them and then add it into the new beaker so that later we will add water up to 100 ml. Okay, so from here, then with very obvious, we already have the idea. M1 equal to 0.25 molar. V1 we have no idea. M2 0.05 molar and volume after dilution is 0.1 liter. Okay, we always use in the unit of liter, so you can convert directly. So do keep in mind that the number of mole of solute does not change. Only the volume of solution is changes when dilution is carried out. So that's why we are going to use the formula M1V1 equal to M2V2. Okay, so then we will notice we need to find transfer 20 ml of 0.25 molar potassium dichromate 6 into a new beaker, and then we add in another 80 ml of water. Then we will able to get a solution which the concentration is 0.05 molar and then the volume is 100 ml. Next idea that we need to recall back is the concept of titration. So as we already know, titration normally will involve the reaction between acid and base. So this is the example, acid and base given. And then the apparatus that used in the lab is the burette and also the conical flask. So basically titration and dilution will be more focused in the lab part. So substance in the burette normally we will know it as titrant, while substance that we put into the conical flask will known as analyte. Okay, so formula that we always use to do the calculation for the concept of titration is MAVA over MBVB equal to A over B. So I think there is no problem for you to understand. M is molarity, while V is the volume. So these A and B are coefficient in balance chemical equation. So you will notice the formula will become MAVA equal to MBVB if the ratio is 1 to 1. But in this case, the ratio, if we look at here, is 1 to 2. So A, let's say A refer to acid, so here will become 1. And then B is referred to base, so here will become 2. So basically, formula M1V1 equal to M2V2. Normally, we used to do the calculation for dilution. Okay, while MAVA over MBVB equal to A over B is for titration. If the ratio is 1 to 1, then the formula can become MAVA equal to MBVB. Okay, so we continue with last example before we end this video. A 25 ml of HCl is titrated with sodium carbonate solution of 0.15 molar with 21.2 milliliter to complete the combustion. So now we want to calculate the concentration of HCl. Means that we want to calculate the MA. So before we start again, basically this is a chemical reaction. So first step, we always have the chemical equation. Okay, so next second, we are going to use the formula MAVA over MBVB equal to A over B. So in this case, acid based on here, the coefficient is 2. Okay, while the sodium carbonate, no number here, means that the coefficient is 1. So now, after decide to use the formula, then we substitute the value into the formula, and finally we able to determine the concentration of the HCl is 0.254 molar. Okay, that's all for this video. So I hope you can get the idea of the limiting reactant and then how to use limiting reactant to determine amount of product produced and the mass of the excess reactant left over, and then able to determine the percentage yield. So please do more exercise in Chem Friend question. Thank you for your attention.